up, y'all? Coach Johnson in the house, 5.1 to 5.2. Hope you're having a great day today. We're ready to get it underway. We got our quiz tomorrow. It's a quick review, about 10-15 minutes. Hopefully it's helpful for you. Without further ado, let's get this show on the road. Today what we've got is a little bye action. There we go. We're going to go into example 2 here. Make sure I'm logged in. Excellente. Perfect. Let's go to example 2 here. First thing we want to do is we want to choose the toughest side. In this instance, we have 1 over 1 minus sine, right? Make sure we're here. Awesome. 1 minus sine plus 1 over 1 plus sine. Awesome. Okay, so one thing that we want to do, actually before that, let me make sure all is well. One thing that we want to do when we come to a problem like this is if we want to first make sure that we have common denominators. That's a pretty big deal. Again, just as we progress forward through a lot of this stuff, you're going to start noticing that it's very important that common denominators that we can get that there. So in this instance, we're missing a 1 plus sign, so we're going to put 1 plus sign on this side. Okay, and on this side, we're going to do 1 minus sign. Okay, and what I do to the bottom, I'm going to end up doing to the top. So I got 1 plus sign here. And on the top, we're going to do 1 minus sign. This pen's not working real quick. There we go. So on the bottom, since we have a common denominator on both sides, 1 plus sign times 1 minus sign we can distribute, right? So 1 to 1 here and here. So 1 times 1 is 1. 1 times negative sign is negative sign. Sign times 1 is positive sign. And sign times negative sign is negative sign squared. Okay? Perfect. So in this instance, since we've got both of these, we know that that within this, the signs will cancel, leaving me with 1 minus sine squared as the bottom side. Make sure that's in at least a little bit. Good. So we have 1 minus sine squared, which what is 1 minus sine squared? Well, we know that that is going to be cosine squared. Okay. That is cosine squared, 1 minus sine squared from my Pythagorean identity. So what I'm saying is that the whole bottom is going to be cosine squared. So what I'm going to do is I'm going to delete this. I'm going to keep going. So on the top, we have 1 plus sign on the top. Over here, 1 minus sign would be times this side. So we're going to keep that there. So we have plus 1 minus sign. And this is going to be all over 1 minus sine squared, but we already figured out that that was cosine squared. So as I keep progressing, you're going to start noticing that the 1 plus 1 would be 2. Signs are going to cancel. So I'm going to have 2 over cosine. Now, 2 over cosine, if we were to simplify this, cosine when it's on the bottom, we could simplify 2, and I'll put it down here. Really, it should flow down. But 2 over cosine is the same as 2 secant of theta. And that should be my answer. So 2 secant of theta will be my answer for that specific problem there. Okay? Awesome. Let's go to another one. Let's do number, let's see here. Let's go to example 5 is a good one. Example 6 is a good one. Let's do example 5. So example 5, we're going to start on the left side, and we're going to use since there's nothing squared, we can't go to Pythagorean identities. So when in doubt, change it into sine and cosine. So let's go 1 over cosine plus sine over cosine here. Okay? All right, perfect. So what we're trying to do is we're trying to get a common denominator. And as I look at that, I notice that, well, I've got 1 over cosine, sine over cosine. I know I could get 1 plus sine on the top and cosine on the bottom, okay? But the problem is that doesn't really take me anywhere. Really didn't do much. So in that instance, I could go 1 over cosine, but that would be getting back to this direction. and we want to keep going downward. So we're going to freeze it on this side, and we're going to go over to the right side, and that's not wrong. We could just go to that side. And since I have cosine over 1 minus sine here, what I could do is I could end up multiplying this by the conjugate. So let's go 1 plus sine here, both top and bottom. Okay, to where when I do that, I get 1 minus sine times 1 plus sine, which we figured out on the other one was 1 minus sine squared. Okay, and on the top, when I multiply by cosine, I could get cosine times 1 plus sine, and I could continue. And that would be okay, but let's do this before we move forward on this. Let's just go cosine times 1 plus sine. Perfect. So one thing that I note is that 1 minus sine squared is cosine squared. So really this we could replace with cosine squared. So what we have now is cosine over 1 plus sine over cosine squared. So one of the cosines will be canceled, both top and bottom, leaving me with a cosine on the bottom. So now I'm left with 1 plus sine over cosine. Well, I look back over on my red side, the left side, and I noticed that when I broke it down, I noticed that 1 plus sine over cosine actually goes back to 1 over cosine plus sine over cosine, which pushes me back to secant plus tangent. So really, I could go here, then here, then here, then here, okay? And so again, that's just a way to, again, as we break this down, as we keep going, it's just a way that we can break them down in moving forward, okay? Again, look over here on this one, another common denominator one. In fact, let me go backwards before this one. Here's another one too where you probably would multiply by 1 minus cosecant, both top and bottom. Again, if you see something like that to where it's by itself like that, if you multiply by 1 minus cosecant, it allows us to use our Pythagorean identities and moving forward. So that may be something too that you do as well. Let's do one more here. I'm trying to think which one. Let's do, in fact, let me edit this. I'm going to go to perfect. I'm trying to see if there's a good one. Okay, let's do B. Okay, B. We know the right side's the hardest, and so we're going to take that right side and say, is there anything I could take to the outside? Well, I could take, since this has a 4, this has 6, I could take cosine of the 4th to the outside. And I'm left with sine on the outside too, because that was already put there. So what's left over on the inside? Well, if I take 4 out, I'm left with 1. And if I take a 4 out and there's 2 left over, I still have 2, right? So cosine squared. So when I took out a cosine of the 4th to the outside, I'm left with 1 minus cosine squared. Well, I know that this is an identity. In fact, if I remember this is my identity, right? Sine squared plus cosine squared equals 1, right? Okay. So if sine squared plus cosine squared equals 1, what I can do now is, it should be equals there. If I subtract cosine squared on both sides, what I have now is sine squared equals 1 minus cosine squared. So in place of 1 minus cosine squared, I could put in sine squared. So I've got sine squared times cosine to the 4th sine. Perfect. And so sine squared times sine is sine to the 3rd. So I have sine to the 3rd cosine to the 4th, and that's where I'm going to include the x again, right here and right here. And that's what it equals, right, to this side. Start on my right, move to my left. One other problem you want to make sure of is if I tell you, like, let's say sine of x equals 27 over 20, right? And then or actually it would probably be 27 over 28, let's say. And I say tangent of x equals square root of 2 over 5, right? If I said solve for all 6 trig ratios, know how to do that. I'm going to set tangent. I know tangent is sine over cosine. So if I know tangent of x is equal to sine over cosine, I know sine is, write this. Sorry about this. My pen's not functioning great. Sine would be 27 over 28. Again, cosine would be x, because I don't know what that is. And the tangent would be square root of 2 over 5. So how do I get x by itself? Well, I can multiply by x and then divide by square root of 2 over 5. Really, these two are flip-flopping. So in doing that, I do 27 over 28 divided by square root of 2 over 5, flip the square root of 2 over 5 to the top to solve for what cosine is. Once I solve for cosine, I can flip it, find the reciprocal of them to find cotangent, cosecant, and secant there. Okay? All right, fantastic. I hope this was helpful for you. I know that there was a lot of questions on that. If you have any more questions, please let me know. Other than that, have a fantastic day. We'll see y'all later. Bye.